Okay, so this is my hexadecimal adder slash subtractor that I made in Minecraft. So just an example here. We have 4 inputs, 4 digits in each input, but of course you could expand this to how many digits you want. But it uses a rippled carry adder, so that means it's kind of slow. If you would add more digits, it would increase the computation time. So on input A we have 7, 8, 8, 2, and on input B we have 1, 3, 9, 6, C. So if we would compute that using subtraction, we would get 6, 4, E6, and that is just what we get using a calculator. And then if we can easily switch this to the addition result, then we get 8C, 1E, and then that's also what we would expect. Yeah, so that's how this works. Also, if we, for example, remove the 7 here, so this first digit is 0, we would get another result here on addition, but on subtraction we get a negative result, and we see this indicated here on the light here, negative B1A. Okay, so how does this machine work? So we have kind of this adder slash subtractor is divided into 3 parts. We have the main subtraction module here. We have a module here and here that are identical that compute the complement. So that's the hexadecimal complement. So that's taking 1, 0, 0, 0, 0 minus the input. So in subtraction mode, the signal is routed through both of these complements and just go straight into the subtraction and then out onto the screen. But if we use if we switch this to addition, these blocks will shift and the input will instead go through the complement on the input A, and then it will go through the subtractor, and then the result will also be complemented before it's outputted. And one final thing, if we get a negative result from the subtraction machine, it will also switch this so we compute the complement of the result. And that's basically how computer works when handling negative numbers. You have an overflow bit, and then you need to complement the result to get what you would expect in normal mathematics. So how do you compute hexadecimal subtraction in Minecraft? So this machine doesn't use any normal binary logic. Instead it uses comparators. So comparators have a very fun feature that when you right click on them, it will change to subtraction mode, and in this mode it will take the input from behind and take the input from the side, minus it. So here we have 15 minus 13 is 2. But to be able to use this on a whole machine level, we also need to consider the reverse. So we also need to consider 13 minus 15, because redstone signals obviously don't have, you can't have negative signal strength. And to compute when we need to carry, or in the case of subtraction it's more of a lone actually, we use normal mode here. So that tells us, in this case, it tells us that the input from behind is stronger than the input from the side. But if we would reduce the signal strength at some point here, we see that the side input is stronger than the main input, and then we get 0. So this is how I use So I use the normal comparator mode to compute when we need to loan from the other digits. So I've tried to make this subtractor and adder fairly compact, as you hopefully can see, but there are some drawbacks. So for one, it's not that fast. So because we're using hexadecimal signals, we need to use a lot of comparators, and those adds 1 tick delay per comparator. So that means it's not that quick. For example, if we switch from subtraction to addition, you see it takes a few seconds. Or if we add an input here, yeah. Or maybe we remove this one and maybe add this one instead. You can see it takes like about a second to compute the result. I'm sure you could make this faster by using comparator priming or another technique, but this is what I have right now. So if you would want to use this machine or try to see how it works yourself, it's available as a well-lit schematic. The main part here is the subtractor. We have input A starting from here, this comparator, and input B starting from here, this comparator, and then we get the result out here from this block. And this is the carry logic. We see how the carry is carried upwards to the next layer.